This video is about rational functions. 1a. Let f of x equals 2x plus 6 over x squared plus 6x plus 10. X is all real numbers. Show that f of x has no vertical asymptotes. If we want to prove f of x has no vertical asymptotes, we have to prove the denominator of f of x cannot be equal to 0. So for x squared plus 6x plus 10, we will change into vertex form. Y equals a times x minus h squared plus k. We know a equals 1, b equals 6, h equals negative b over 2a equals negative 6 over 2 times 1 equals negative 3. And k equals f of negative 3. So negative 3 squared plus 6 times negative 3 plus 10 equals 9 minus 18 plus 10 equals 1. Therefore, for x squared plus 6x plus 10 equals x plus 3 squared plus 1. This always greater than 0. So f of x has no vertical asymptote line. For 1b, find the equation of the horizontal asymptotes. For the horizontal asymptote line, we will use the limit to figure out. Limits as x approaches infinity of f of x equals limit as x approaches infinity of leading term 2x over x squared. Reduce, we will get limit as x approaches infinity of 2 over x equals 0. So horizontal asymptote line y equals 0. Let's go to 2a. Let f of x equals 2x squared minus 5x minus 12 over x plus 2. X is not equal to negative 2. Find all intercepts of the graph of f of x with both the x and the y-axis. For the x-intercept, we will make f of x equals 0, which means numerator equals 0. 2x squared minus 5x minus 12 equals 0. Ninja x, negative 24, negative 5 over 2 over 2. Positive 3, negative 8, reduce, negative 4 over 1. X, bottom up. 2x plus 3 times x minus 4 equals 0. So x1 equals negative 3 over 2, x2 equals 4. For x-intercept, negative 3 over 2, 0, and 4, 0. For y-intercept, we will get f of 0, every single x turning into 0. So we have 2 times 0 squared minus 5 times 0 minus 12 over 0 plus 2 equals negative 6. So 0, negative 6 is the y-intercept. Let's go to 2b. Write down the equation of vertical asymptotes. Vertical asymptotes, we will make a denominator equals 0, which means x plus 2 equals 0. X equals negative 2. To say as x approaches positive and a negative infinity, the graph of f of x approaches an oblique straight line asymptote. Divide divide 2x squared minus 5x minus 12 by x plus 2 to find the equation of these asymptotes. We will use synthetic division because x plus 2 is a linear factor. X plus 2 equals 0, x equals negative 2. So we use negative 2 as the root. No missing power, 2, negative 5 or negative 12. Drop down 2, multiply negative 4, adding negative 9. The oblique asymptote line is the quotient, so we don't have to work on this remainder. So y equals 2x minus 9 is the oblique asymptote line. Let's go to question 3. Decompose 2x minus 4 over x squared minus 1. First of all, we will factor the denominator x plus 1, x minus 1. 2x minus 4 as a numerator. So we have x minus 4 over x squared minus 1. We will write down x plus 1 times x minus 1. Numerator is 2x minus 4 equals a over x plus 1 plus b over x minus 1. We will work out this addition. Cross multiply. We will get denominator x plus 1 times x minus 1. So a times x minus 1 plus b times x plus 1. We are using the formula a over b plus c over d equals bd ad plus bc. So distributive property ax minus a plus bx plus b. Organize a plus b x minus a plus b over x plus 1 x minus 1. We will get this equals this. So we have 2x minus 4 equals a plus b x minus a plus b. The coefficient of x are equal to each other. 2 equals a plus b. Constant number equals each other. Negative 4 equals negative a plus b. Adding so that we can cancel a. Negative 2 equals 2b. So b equals negative 1. And a equals 2 minus b. 2 minus negative 1 equals 3. We get a equals 3 and b equals negative 1. So final answer, we will have 3 over x plus 1 minus 1 over x minus 1. Let's go to number 4. Sketch the graph of y equals 1 minus 3x over x minus 2, clearly showing any asymptotes and stating the coordinates of any point of intersection with the axis. For vertical asymptote line, we will make a denominator equals 0, so we get x equals 2. For horizontal asymptote line, we will get y equals. Since this rational function is a linear over linear pattern, the horizontal asymptote line will be the quotient of coefficient of x. So we have a -3 over 1 equals -3. For x-intercept, we will make a numerator equals 0. 1 minus 3x equals 0. -3x equals -1 divided by -3. X equals 1 over 3. So 1 over 3, 0 is an x-intercept. For y-intercept, f of 0 equals 1 minus 3 times 0. 0 minus 2 equals -1 over 2. So we have 0, -1 over 2 as a y-intercept. We will draw horizontal and a vertical asymptote line first. Then for x-intercept, 1 over 3, 0. For y-intercept, 0, -1 over 2 is here. Label -1 over 2. Then you can sketch the graph. The other part will be here. When it says clearly showing any asymptotes and coordinates of any points intersection with x-axis, which means you have to label on the graph of these asymptotes and intercepts.